Welcome to this explainer. If you've ever scrolled through a news report, glanced at a scientific study, or tried to make sense of an economic breakdown, you have absolutely encountered numbers being used to back up arguments. We literally live in a world driven by quantitative knowledge. But how often do we actually stop and ask, what really qualifies as a valid statistical fact? Well, we're going to unpack exactly that today by looking at Section 16.3, the definition of statistics. Okay, let's dive right into this.
So, are all numbers actually statistics? It's a super common assumption that any figure, any measurement, or literally any isolated number you stumble across is a statistic. Like if someone tells you they have exactly $1,000 in their bank account, is that a statistic? As our source material shows us, the answer is a resounding no. Merely stating a numerical fact doesn't automatically grant it statistical significance.
Section 1. The two faces of statistics.
To really understand why, we first need to look at the word itself. Statistics is actually a pretty fascinating term because it operates with this sort of dual identity. In the singular sense, statistics refers to the statistical methods themselves. Think of it as the science, the actual techniques of collecting, classifying, presenting, and analyzing the data. But in the plural sense, statistics means numerical facts or data related to a specific field of inquiry. For the purpose of this explainer, we're going to focus heavily on that plural definition, the actual numerical data, and what specifically qualifies a set of numbers to earn the title of statistics.
Moving on to Section 2. The search for a definition.
The pursuit of a really precise definition for this plural sense hasn't exactly been straightforward. Early scholars tried hard to pin down exactly what makes numerical data function as statistics. First up, we have the definition from scholars Yule and Kendall. They define statistics as quantitative data affected to a marked extent by multiplicity of causes. And honestly, this is a great starting point. It rightly points out that true statistical data isn't just some flat, boring number, it's quantitative information shaped by a bunch of different intersecting factors and variables.
Let's move to and see how this builds with another perspective, this one from A.L. Boley. He defined it as numerical statements of facts in any department of inquiry placed in relation to each other. Boley introduces another absolutely crucial element here, relationship. He highlights that facts actually have to be placed in relation to one another to mean anything at all.
But of course, there's a catch. While both of these definitions are historically really significant, they each focus on just a single aspect of the data. It's kind of like defining a car purely by describing its tires. I mean, yes, the tires are essential and your description might be perfectly accurate, but you're completely missing the engine, the steering wheel, the chassis, the whole shebang. So they're accurate, sure, but fundamentally incomplete for our purposes.
Which brings us to Section 3, the comprehensive definition.
Because those earlier attempts just focused on isolated bits and pieces, the field really needed something more robust. It needed a gold standard framework that wrapped up all the necessary characteristics of statistical data. Enter Horace Sechrist. His definition in the plural sense reads, aggregates of facts affected to a marked extent by multiplicity of causes, numerically expressed, enumerated or estimated according to reasonable standards of accuracy, collected in systematic manner for a predetermined purpose and placed in relation to each other. Okay, wow. Now, what's really interesting about this is how Sechrist essentially took all those single fragments from the earlier scholars and masterfully forged them into one massive ultimate definition. It is incredibly dense for sure, but it hits the nail right on the head.
Section 4. 4 rules of statistical data.
Okay, I realize that reading Sechrist's definition aloud can feel a little bit like trying to swallow a textbook whole. It's a total mouthful. But if we want to truly grasp what makes a number a statistic, we don't actually need to memorize that massive quote. Instead, we can break it apart into a really satisfying, highly practical checklist. By deconstructing Sechrist's framework, we get these 4 primary characteristics, or rules of statistical data. 1. They must be aggregates of facts. 2. They must be numerically expressed. 3. They must be affected by a multiplicity of causes. And 4. They must be enumerated or estimated according to reasonable standards of accuracy. Let's walk through each of these steps right now so you can see exactly how they play out in the real world.
And this brilliantly illustrates rule number 1, aggregates of facts. Remember earlier when I asked if someone having $1,000 in the bank was a statistic? The answer is no, because statistics should never just be one isolated fact. A single figure can't be compared to anything, which means you can't draw any broader conclusions from it. Stating, hey, there are 1,500 students in our school, has practically no statistical significance on its own. But if you state that there are 200 students in class 12, 300 students in class 11, and so on, well, now you have an aggregate of facts.
Now it makes statistical sense because the data can actually be compared. All right, moving to rule number 2. Data must be numerically expressed. This one might seem super obvious, but it's a vital distinction to make. Non-quantitative or qualitative facts, like saying someone is tall, short, handsome, ugly, or gentle, might be really useful information in your everyday life, but they are absolutely not statistics. To be a true statistic, that observation has to be expressed in cold, hard numbers, like a specific height in centimeters or an age in years.
Next up, rule number 3 requires that statistics be affected by a multiplicity of causes. Take the death rates in a hypothetical town, for example. True statistics are rarely, if ever, influenced by just one single factor in a vacuum. Here, the data relates to multiple causes: accidents at 25%, disease at 40%, hunger at 15%, and heat at 20%. If this data only looked at a single cause, say just the accidental deaths, without any other context whatsoever, it wouldn't truly function as a robust aggregate of facts. Statistics have to reflect the complex, interconnected reality of the real world.
And finally, rule number 4, statistics must be enumerated or estimated according to reasonable standards of accuracy. When you're out there collecting data, you basically have 2 main paths. You can enumerate, which means doing an actual direct count of every single item, or you can estimate based on sound scientific principles. But regardless of which method you choose, a reasonable degree of accuracy absolutely must be strictly maintained. Why? Well, because the entire purpose of statistics is to draw conclusions. A lack of accuracy doesn't just give you bad data, it leads directly to misleading and potentially even dangerous conclusions.
So the crucial point here is that a number alone is simply not enough. To truly count as a statistic in the plural sense, it has to be an aggregate of facts, it has to be expressed numerically, shaped by multiple causes, and gathered with a reasonable standard of accuracy. We've seen exactly how early definitions kind of fell short and how Horace Sechrist gave us the really comprehensive standard that we still rely on today. So next time you see a number pop up in the news, on your social media feed, or in some long report, ask yourself, is this just an isolated figure, or does it actually meet all 4 rules to be a true statistic? Understanding that difference is absolutely key to navigating our data-driven world.